Every mechanic in America does the same thing the moment they climb into a modern truck. Before they check the oil, before they pop the hood, before they do anything else, they reach for the dashboard and they disable auto start stop. Then they turn off traction control. Then, if it is a General Motors truck, they plug in a $40 device to stop the engine from shutting down half its own cylinders. These are not personal preferences. These are professional survival instincts built from years of watching customers get handed repair bills for damage that should never have happened in the first place. Today we are going to show you exactly why they do it and why you should too. Let us start with the feature you already hate: auto start stop. You pull up to a red light in your new truck and the engine dies. The cabin goes quiet. The air conditioning fades. Then you lift your foot off the brake and the whole truck lurches back to life like someone kicked it in the ribs. The dealership told you this saves gas and helps the environment. Here is what they left out. When your engine is running, the crankshaft floats on a microscopically thin film of pressurized oil. Engineers call this hydrodynamic lubrication. The metal surfaces of the crankshaft and the bearings never actually touch. They are separated by oil pressure, and that separation is what lets an engine survive 300,000 miles without the bottom end wearing out. Now, the automakers are not stupid. They know that every time the engine shuts off, that oil film thins out and the crankshaft settles closer to the bearing surface. They know that every restart creates a brief window where lubrication is reduced before full oil pressure rebuilds. So they engineered around it. Modern start-stop vehicles use heavier duty starters with needle bearings instead of bushings. They use reinforced ring gears, and the engine bearings themselves have been upgraded with polymer-coated surfaces specifically designed to resist the friction of repeated restarts. Federal Mogul, one of the largest bearing manufacturers in the world, developed a proprietary coating that cuts the friction coefficient in half compared to a standard aluminum bearing. They also redesigned their bearings to handle 250,000 to 300,000 start cycles, up from the 100,000 that a conventional engine bearing was built for. And that right there is the confession hiding in plain sight. They had to triple the durability rating of the bearings because the old ones could not survive the system. Think about what that tells you. The manufacturer's own supplier looked at auto, start-stop, and said, "The parts we have been building for decades will not hold up. We need to re-engineer the bearing to keep it from failing prematurely." A conventional engine without start-stop goes through roughly 50,000 start cycles in its entire life. A truck with auto start-stopping can accumulate 300,000 to 500,000 start cycles before the odometer hits 200,000 miles. Even with the upgraded starters and the polymer-coated bearings, you are still multiplying the single most destructive event inside your engine by a factor of 5 to 10. The upgrades do not eliminate the wear. They manage it. They slow it down. But they do not stop it, and every cycle still chips away at the lifespan of every component in the chain: the starter, the ring gear, the battery, and the bearings. And the fuel savings that are supposed to justify all of this? In real-world driving, auto start-stop delivers somewhere between 3 and 5% better fuel economy. On a truck that gets 20 miles per gallon, that is less than 1 extra mile per gallon. Maybe $50 a year in saved gasoline. The heavy-duty AGM battery. The system requires costs $200 to $300 to replace. The beefed-up starter, when it finally wears through its cycles, runs $400 to $800. You will spend more replacing the components this system burns through than you will ever save at the pump. The math does not work for the person behind the wheel. It was never supposed to. It works on a corporate average fuel economy compliant spreadsheet in Detroit, and that is the only place it was ever designed to work. But auto start-stop is just the appetizer. The next trick is even more cynical. If you have shopped for a full-size truck recently, you may have noticed something odd on the window sticker. Where a naturally aspirated V8 used to be the standard powertrain, automakers are now pushing small displacement turbo engines as the default. Chevrolet offers a 2.7-liter turbocharged four-cylinder in the half-ton Silverado. Ford has been running EcoBoost turbocharged V6 engines across the F-150 lineup for over a decade. The pitch is simple: V8 power, small engine fuel economy. And on the EPA test cycle, the numbers back it up. In the real world, the story gets more complicated. Now, to be fair, at a steady highway cruise, a modern turbocharged engine is not working particularly hard. The boost pressure is low, the cylinder temperatures are manageable, and the turbo is spinning well below its maximum. On a flat highway at 65 miles per hour with no load, a small turbo engine and a big V8 are both loafing. The difference shows up the moment you actually need the power, merging onto a freeway, climbing a long mountain grade in the Rockies with a family and luggage, towing a boat up a launch ramp, pulling a camper through a headwind across West Texas. That is when the turbocharger spools up past 100,000 revolutions per minute, the exhaust gas temperatures spike, the intercooler is working at full capacity, and every internal component in that small engine is operating under pressures and thermal loads that a naturally aspirated V8 doing the same job simply never experiences. A 5.3-liter V8 towing 5,000 pounds up a grade is working at maybe 60% of its capacity. It has the displacement to produce that torque without forced induction, without extreme cylinder pressures, and without exhaust temperatures hot enough to glow the manifold. A 2.7-liter four-cylinder pulling the same load has to manufacture that torque through boost pressure, and that means heat, stress, and mechanical complexity that compounds every single time you ask the engine to actually work. And the complexity is the real cost. A naturally aspirated V8 does not have a turbocharger to fail. It does not have an intercooler to leak. It does not have a wastegate to stick. It does not have boost control solenoids or charge pipes or oil feed lines to the turbo bearing cartridge. Every one of those components is a potential failure point that did not exist on the engine it replaced. And when a turbo seal lets go, you are not looking at a minor repair. You're looking at $2,000 minimum, and that bill can climb past $4,000 depending on the truck and whether the failed turbo sent oil into the intake or metal fragments downstream. The old-timers had a saying, "There is no replacement for displacement." The engineers in Detroit know that is true. They did not choose small turbo engines because they last longer or because they are more reliable. They chose them because a smaller displacement number scores better on the EPA test cycle, and meeting that number is the only engineering priority that matters when CAFE penalties are on the line. If you are learning something from this, hit subscribe. We break down the engineering tricks the automotive industry hopes you never understand every single week. Now let us talk about the worst one. This technology is not a theory, not a maybe, not a long-term concern. It is an active class action lawsuit, and it has already destroyed thousands of engines. General Motors has spent the last decade installing a system called active fuel management, and its newer version called dynamic fuel management in nearly every V8 truck and SUV they sell. The Silverado, the Sierra, the Tahoe, the Yukon, the Suburban, the Escalade. If you bought a General Motors V8 after 2014, your engine almost certainly has it. The idea is straightforward. When the truck is cruising at highway speed and does not need full power, the computer deactivates some of the cylinders. The engine burns less fuel, the fleet average goes up, and General Motors gets closer to hitting its corporate average fuel economy target. On paper, it is elegant. Inside the engine, it is a disaster. The hydraulic lifters that make this system work are the weak point. Active fuel management lifters and dynamic fuel management lifters have to rapidly switch between active and deactivated states thousands of times per highway trip, and they fail. They collapse. They get stuck in the wrong position, When a lifter collapses inside a running engine, the push rod above it bends. The camshaft lobe that was riding on that lifter gets chewed into scrap metal. Shavings scatter through the oiling system and contaminate every bearing surface in the block. If you catch it early, you are looking at a lifter and camshaft replacement that runs $6,000 to $8,000. If you do not catch it in time, you need a new engine. This is not speculation. A class action lawsuit filed in the United States District Court for the Eastern District of Michigan covers 2014 to present model year Chevrolet, GMC, Buick, and Cadillac vehicles equipped with the 5.3-liter, 6-liter, and 6.2-liter V8 engines. The suit alleges that General Motors sold millions of these trucks knowing the AFM lifters were defective in design. And as of early 2026, a federal judge denied General Motors' motion to split the case, keeping the entire consolidated lawsuit intact across both AFM and DFM systems. The owner stories are brutal. A 2019 Silverado Trail Boss had lifters fail at 12,500 miles. Warranty covered it. 54,000 miles later, the same failure happened again, and the owner needed a complete engine replacement. A 2015 Sierra Denali owner paid over $10,000 out of pocket at 124,000 miles. A 2023 Escalade had its engine fail at 9,000 miles, brand new, and received a replacement engine built with the exact same parts. That is the detail that makes this truly unforgivable. When General Motors replaces the failed lifters under warranty or at the owner's expense, they install the same components with the same design. The repair does not fix the problem, it resets the countdown. Owners on the General Motors forums describe it as paying thousands of dollars to restart a clock that will run out again. The aftermarket solved this problem years ago. An electronic AFM disabler module costs between $30 and $100, plugs into the OBD2 port under your dashboard, and keeps all 8 cylinders firing all the time. Owners who installed one early report 0 lifter failures across hundreds of thousands of miles. The ones who left the factory system active are the ones writing 5-figure checks to the service department. Every single one of these technologies, auto start stop, small displacement turbo engines, and cylinder deactivation, exists for the same reason. Not to build a better truck, not to save the owner money, not to make the engine last longer. They exist because the corporate average fuel economy target says the fleet has to hit a number, and Detroit will engineer around the durability of your powertrain to get there. The fuel savings are measured in pennies per tank full. The repair bills are measured in thousands. The automaker passes the compliance test. You get the invoice. The first thing any informed owner does on day one is disable every one of these systems. Turn off the auto start stop system every time you start the truck. Install an AFM disabler if you own a GM VAM8 engine. If you are shopping for your next truck, find the option sheet that still has a naturally aspirated V8 engine without cylinder deactivation, because that list shrinks every single model year. What is the first button you press when you get into a new rental car? Drop it in the comments. If this video just saved you from a surprise at the service counter, hit subscribe. We'll see you in the next one.